Okay, good morning. Here we have day one of the Easter revision, which is all about angles. So first question is this. ABCDE is a pentagon. That's got 5 sides. Angle BCD equals 2 times angle ABC. Work out the size of angle BCD. You must show all you're working. First of all, I've got my 90 degrees down here. But also I've got this is a pentagon. So I need to find the total of the interior angles. So 5 is the sides, take 2 times by 180. That always works out the triangles, which is 3 times 180. So the total interior angles is 540. Then read this, angle BCD is 2 times angle ABC. That means that angle ABC is the smaller one. So I'm going to call ABC, that's this one, x, BCD, 2x. What I can then do is form and solve an equation, x plus 2x plus 125 plus 115 plus 90 equals 540. That's 3x. 125 plus 115 is 240 plus 90, that is 330 plus 330 equals 540. Solve the equation, take 330, so 3x equals 210, divide by 3, x equals 70. So if I sub in, that's 70, that is 140, which is 2 lots of 70. Work out the size of angle BCD. Well, angle, we sometimes write it like that, equals 140. Okay, first one done. Next one, diagram shows a hexagon. The hexagon has one line of symmetry. That means it's got a line down the middle, which splits it in half. And so it's the same both sides. FA equals BC, they're both marked. EF equals CD, they're both marked. Angle ABC is 117, I can see that, and angle BCD equals 2 times angle CD, a bit like the last one. Work out the size of angle AFE. You must show all your work in. AFE is this one, and in fact it will be exactly the same as BCD. I can also see that this one is exactly the same. And now, so hexagon, hexagon's got 6 sides, so 6 take 2 times by 180 equals 4 times 180, which is 720. So the total angles in the whole shape of the hexagon is 720. Angle BCD is 2 times angle CDE, so CD would be x, that would be 2x, so CDE is this angle, which is x, that is 2x. Because of the symmetry, that is 2x, and that is also x. So what I've got is x plus 2x plus 2x plus 117 plus 117 equals 720. X plus 2x is 6x. Oops. So 6x plus 234. Let's get the right pen on. Equals 720. Take away the 234. Take the 234. So it gives me 6x equals, let's do this, 1, 10 take 4 is 6, 6, 1, 11 take 3 is 8, 6 take 2 is 4, so that's 486. Divide by 6, x equals 6 into 48 or 8, 6 into 6 or 1. So x equals 81, 2 81s are 162, 2 81s are 162, and as I want AFE, angle AFE equals 162, which I've drawn on there, great. Next one, diagram shows triangle ABC, yeah, ADB is a straight line, yeah. size of angle DCB, D to C to B, that is this one, to the size of angle A to C to D, which is this one, is 2 to 1. So if I called this one X, which is the smallest one, that would be 2X. Work out the size of angle BDC. In this case, it's that angle I want. I'm just going to call that Y in this case. So first of all, if I look at this triangle, okay, which is ABC, I can see that I've got X plus 2X, that makes this big angle here, plus 75 plus 51 equals 180 because it's a triangle. That's 3x plus, that's 126 equals 180. Take the 126, take the 126, 3x equals, that's 54. Divide by 3, so x equals 18. So that means that angle there is 18, that angle there is 2 18s, which are 36. Now to find my angle BDC, which is y, I can just say that y plus 36 plus 51 equals 180 because it's a new triangle, i.e. that triangle there, and that gives me y equals, no, y plus, sorry, 87 equals 180. So take the 87, take the 87, y equals 93, and that in fact is angle BDC, which equals that. Good, that's that one done. Right, here we've got BEG is a triangle. Oops, I've got, looks like I've already got the answer written down there because I did this wrong earlier. Well, no, I recorded it wrong. What I've now got is ABC and DEF are parallel lines. So I can see the parallel with the little arrows, work out the size of angle X, give reasons for each stage you're working. I'm going to have some form of, know something about parallel lines. With this question, if I look at this angle here, because these two are parallel, this angle here is going to be 70 degrees because these two add up to 180, and they are called allied angles or co-interior, depends how what you've been taught. Angles add up to 180 degrees. Okay, never put they equal, they always add up to. Once I've got that 70, of course I can look at this angle here, which is actually 180 take, well I've got 70 plus 35, which is 180 take 105, which is 75. So this angle here is 75, and the reason is angles on a straight line add up to 180 degrees. Always remember that one, it will always get you a mark. Now, when I've got that, I've got, this is also angles on a straight line. So I've got here 180 take 110 plus 25, which is 180 take 135, which is 45. So this angle here is 45, and so x x plus 75 plus 45 equals 180. X plus 120 equals 180. Take the 120, take the 120. So x equals 60. And the reason for that is angles in a triangle. Oops. Add up to 180 degrees. So I've got one over here, this one with the allied or interior angles, co-interior angles. There's my parallel line ones, but I'm also got straight line. I've also got angles out up to 180 degrees. So that's a good one. Always remember the angles in a triangle. Always remember the angles on a straight line. Right, finally, ABC and DEF are parallel straight lines. I can see that there. ABC is an isosceles triangle. AB and BC are the same. I can see that. Angle CBE, which is marked as 142, work out the size of angle X. First thing on here, because of my isosceles, well, first of all, I've got a straight line here. So 180 take 142 equals 38. So this angle here is 38. Angles on a straight line add up to 180 degrees. Then I can also look at these two angles. These two angles being base angles in isosceles triangles. So 180 take 38 equals 142. 142 divided by 2 equals 71. So these are both 71, and that is because base angles in an isosceles triangle are equal. And then I'm going to use this one. I also know that this one, X is 71, and that is because when you've got parallel lines and you've got a line, this line I'm just going over is called the transversal. When you've got angles either side, makes a Z angle. What we can do is we can say that they are called alternate angles are equal. Okay, I could have also done, if you looked at the alternate angle, this one and this one here are also alternate angles are equal. So that would apply to that as well. And then I've got 38, 71 is 109, from 180 is 71. So different ways of doing that. But once again, there's angles on a straight line. We've also got the base angles in the isosceles triangle, and we've also got the alternate angles are equal. Okay.